We are Team Project Work 4432 and we are excited to present our project on data analysis. Today we will walk you through the different stages of our work including data processing, statistical analysis and data visualization. In our team we have me, Srijan Poudel. I will be covering the dataset overview and initial exploration. Next we have Durga Bahadur Basnet. He will explain the data processing steps. And we have Subham Luitel. He will take you through the statistical analysis and calculations. And next we have Subash Chhetri. He will demonstrate the visualizations and insights we drew from the analysis. Now let's start with a quick overview of the datasets and the tools we used. We choose the dataset weather history, which contains 9,000 which contains 96,453 rows and 12 columns. Our dataset includes various numerical and categorical variables, which we made it ideal for statistical analysis. To begin, we used Python and Jupyter Notebook for this project. We explored the dataset by viewing random samples and identifying the number of missing values each in columns. We also checked the duplicate rows and handled them accordingly. Next, Durga Bahadur Basnet will take over to explain the data processing steps.
Okay, thank you, Mr. Srijan Poudel. For data pre-processing, we performed several tasks which are as follows. Number one, handling missing values. We calculated the percentage of missing data in each column and decided on appropriate methods for handling them. For example, we filled missing values in the precept type column using min method, and we dropped rows with significant missing data. And now number two, removing duplicates. We identified and removed duplicate rows to ensure the dataset's integrity. And now number three, attribute types. We classified the datasets columns into different attribute types: nominal, ordinal, binary, and continuous attributes. And now, next, Mr. Subham Luitel will take over to explain our statistical analysis. Thank you.
Thank you, Durga Bahadur Vasnet. Now, in this part, we focused on the humidity column from the data set of weather history and calculated three key statistical measures: mean, median, and standard deviation. The first one is mean. The mean humidity value is exprop 0.735, that is 73.5%. This represents the average humidity across all the data point in the data set. It gives us the general idea of the central tendency of humidity values. A median. The median humidity is 0.78, that is 78%. The median in the middle value when the data is stored in ascending order. It indicates that half of the data points have humidity below 78% and the other half have humidity above 78%. The mean, the median is particularly used for understanding the central value, especially when there are outliers in the data. Standard deviation. The standard deviation is across 0.196, that is 19.6%. This measure tells us about the spread or validity of the humidity value around the mean. A lower standard deviation would indicate that most humidity values are close to the mean while the higher value shows more validity. In summary, the average humidity is about 73.5% with a slightly higher median of 78%, suggesting that the slight skew in the data. The standard deviation of 19.6% shows moderate variability in the humidity level across the dataset. Now, the data plot are shown by my next colleague, Subash Chhetri.
Thank you, Subham Luitel. Here, visualizations played an important role in uncovering patterns and insights from our data. Here, we used Matplotlib to create two plots. First one is line plot. Here, we started with a line plot to examine how humidity changes across the data set. The x-axis shows the data points and the y-axis represents the humidity level. The x-axis shows this plot highlights ups and downs, showing how humidity varies over time. And the second one is histogram. Here, we created a histogram to see how often different humidity values occur. We divided the data into 10 bins and found that most humidity values were grouped towards the higher end, showing that higher humidity levels are common in the database. This visualization helps us to uncover key trends and correlation which we will now summarize. From here, Durga Bahadur will take up for that part. Thank you.
Okay, thank you, Subhas. To conclude, through our analysis of the weather forecasting history dataset, we gained valuable insights into how different weather variables interact with each other. Our key findings include number one, humidity trends, number two, temperature and wind speed correlation, number three, precipitation type. Through data cleaning, statistical analysis, and visualization, we were able to extract meaningful insights and trends from the data, leading to a better understanding of weather patterns. Thank you for your time, and we look forward to any questions you may have. Thank you.